Hello there, Mr. Sutton here, bringing you the Algebra 2 8-5 homework solutions on the probability of disjoint and overlapping events. For this problem and the next two after, we have a spinner where each part here has the same area, and they want to find the probability of certain events. So this time around, they want the probability of spinning blue or a 1. So let's take a look and see if there's any overlap between these two groups. So we don't have any ones that are also blue, so these would be disjoint, and we'll use our disjoint formula, which is just P of A plus P of B. In this case, A is blue and B is spinning a 1. The probability of blue, and there's 12 spaces here it looks like, so blue is going to be 3 out of those 12. Probability of a 1 is just 1 out of 12, so we just have to add these together. 3/12 plus 1/12, which comes out to 4 over 12, or I could reduce that to 1/3. On this one, we want the probability of spinning red or an odd number. So let's look at our odd numbers and see if any of those are red. Well, 11 is red, so is 5. So we have some overlap, and we're going to use our overlapping formula, P of A plus P of B minus P of A and B. So in this case, A is red, and event B is odd. The probability of red, P of A, is going to be 1, 2, 3, 4 out of 12. Probability of odd is literally half of the numbers from 1 to 12, so 6 out of 12. And the probability of meeting both conditions, we have a 5 and an 11 that are red, so that's 2 out of 12. So just putting it all together, we've got 4/12 plus 6/12 minus 2/12. That's 10 over 12 minus 2 over 12, which is 8 over 12, and that reduces to 2/3. For the probability on this one, we're trying to figure out the chances of spinning an even number or a prime number, even or prime. So are there any even numbers that are also prime numbers? Well, yes, there's exactly one, and that is, ironically, 2. 2 is an even prime number, so there's some overlap. So we're going to have to do our overlap formula, P of A plus P of B minus P of A and B. So let's do a probability of an even number first. So there, and let's let A be evens and B be primes. So even numbers, there's 6 of them on here. 2, 4, 6, 8, 10, and 12. So 6 out of 12. For prime numbers, let's go through. Now 1 does not count as a prime number. 2 does though, so we have 2, 3, 5, 7, and the only other prime number is 11. So that's going to be a total of 5 out of 12. And now even numbers that are also prime, again just 2, so 1 out of 12. So we have 6 out of 12 plus 5/12 minus 1/12. So we have 11/12 minus 1/12, which is 10/12. And that reduces to 5 over 6. On this problem, we want the probability of drawing a heart or a face card from a standard deck of 52 cards. So is there any overlap between these groups? Well, yes, there are some face cards that happen to be hearts. So because we have overlap, we'll use our overlap formula, P of A plus P of B minus P of A and B. A in this case is drawing a heart. B is drawing a face card, and then P of A, there are 13 hearts in a deck, so 13 out of 52. Probability of a face card, there's 12 of those in a deck, 3 for each of the 4 suits, so 12 out of 52. Face cards that are also hearts, this would be P of A and B. So that's going to be the King, Queen, and Jack of hearts, so 3 out of 52. Putting it all together, we've got 13 plus 12 minus 3, all of those over 52. So this is 25 minus 3, which is 22 over 52, and that reduces to 11 out of 26. So for this problem, we're performing an experiment for a science project to see how well plants grow under different light sources. We have 30 plants in the experiment, 12 receiving visible light and 15 ultraviolet light. And then we have 6 that receive both. We want the probability that a plant receives visible or ultraviolet light. So we're looking for a P of A or B kind of situation. So let's identify our events. So one possibility, we'll call it A, is that we get visible light. The other, which we'll call B, is the ultraviolet, the UV. And since we're looking for the probability of OR, we have to figure out if this is overlapping or disjoint. And they said here that 6 receive both types of light. So this is an overlapping situation. And we will use our overlapping formula, P of A plus P of B minus P of A and B. So P of A, that was the probability of the visible light. That was the 12 plants divided by the total of 30. P of B, the UV, that was going to be 15 over 30. And P of A and B, that's the one that got both lights, so that was 6 out of 30. So putting this together with our formula, we have 12 plus 15 minus 6 over 30. So this is 27 minus 6, which is 21 over 30. And I can reduce that to 7 over 10. On this next one, we have a group of 40 trees in a forest not growing properly. A botanist figures out 34 of the trees have a disease or are being damaged by insects. And they also tell us that 18 have the disease, 20 have the insects. We want the probability that a poor tree has both the disease and the insects. So for this one, let me identify my events. One of them is the disease. We'll call that A, and we'll let B represent the insects. And in terms of overlapping versus disjoint, they're asking for the probability that something has both of these. So we're looking for an overlapping set, which means we need our overlapping kind of formula. So we're going to go with P of A plus P of B minus P of A and B. But now, since we're looking for the overlapping piece and not the OR piece, we're going to rearrange this to get P of A and B by itself. So I'll add P of A and B over to the left side, subtract P of A or B over to the right side, so basically switching those. And now I have a formula that's going to tell me exactly what I want to know with the information that I have. So P of A, that was the probability of having the disease. They said 18 trees have the disease out of 40, so 18 out of 40. P of B, the insects, that was 20 out of 40. And we're really going to resist the temptation to reduce this to 1/2, because then we'll just have to unreduce it later to add the fractions. Now P of A or B, they said that 34 trees had the disease or the insects, so 34 out of 40. Putting all this together, we have 18 plus 20 minus 34. That's 38 minus 34, which is 4, so 4 out of 40, which I can now reduce to 1 out of 10. On this one, we have a company focus testing a new type of fruit drink. Focus group is 47% male. Of the responses, we're told that 40% of the males and 54% of the females would buy the fruit drink. We want the probability a randomly selected person, male or female, would buy the fruit drink. So what we're going to do, there's some conditions going on here. We've got the 47% males, but only 40% of them would get the drink. And then we have the 53% females, 54 of whom get the drink. We're going to make a tree to kind of show all this here. So I'm going to have 2 events in this one. We're going to let event A be whether or not the respondent is male. We could have made it female, but we've got to pick one. And then we've got event B being they would buy the drink. So event A, we have 2 possibilities, male or not male. So we've got probability of A is going to be 47%, and probability of not A, then we'll just do 1 minus 0.47. We will assume all the subjects of this study are binary, even though we know that in real life setting that's not necessarily the case. So we'll just say 0.53 for not A. All right, now given these probabilities, we're going to dig deep into the would buy part of the event here. So given that we have a male, the probability that they would buy, P of B given A, is going to be 40%. If we have a male, the probability that they would not buy then, so P of not B given A would be the remaining 60%, so 0.60. If our participant is not male, in other words, female, that means probability that they would buy is going to be 54%, 0.54. And then probability that they would not buy, given that they are not male, would be 100% minus this, so that would be 0.46. So if we want to know the probability that a person would buy the fruit drink, we're looking for males that would buy it, so probability of A and B, given A. And also, we want to add that to the probability that a not male, a female, would buy the drink, so probability of not A and B. So in terms of numbers, that means probability of A, that's 0.47, times conditional probability of B, given A, so 0.4, plus we've got 0.53 times this 0.54 here. And now for the calculator. So plug in all this in, we've got 0.47 times 0.40 plus 0.53 times 0.54, all coming out to about 0.474. So we have about a 47.4% chance a randomly selected person will buy the drink.